Okay, so now we're on the back side. First question. We've got an isosceles right triangle, and we're trying to figure out what the legs of this triangle would be. So, I don't know if I have my formula chart. Okay, so don't forget that you have these formulas, or you have the rules on your formula chart. So here's your 45, 45, 90 rules and your 30, 60, 90 rules. They're on here. You don't have to memorize them. So this is our 45, 45, 90, which we know because it has two congruent sides. Okay. So then these two sides are our x's, and this represents our x square root 2. You can treat this like an algebra problem. We know that x square root 2 is equal to 7 square root 18. In order to get x by itself, we would have to divide by the square root of 2. So then those cancel. Now, when you're dealing with numbers like this, you can't mix a whole number outside with a number on the inside. So the 7 stays outside by itself, nothing happens to it. But on the insides, okay, 18 divided by 2 is 9. So this is 7 square root 9. Now, if this was a fully reduced square root, then I would stop here. But this isn't fully reduced because the square root of 9 is a perfect square, meaning that you can take the square root and get a whole number. If you type 7 square root 9 into your calculator and hit enter, it gives you 21. This is because the square root of 9 is actually 3. 3 times 7 is 21. So your real final answer is 21. Okay, number 11. In rectangle JKLM, the measure of angle KLJ is twice the measure of angle KJL. What is the base and height of the rectangle? Okay, this is a clue that this is a 30, 60, 90 triangle. Okay. So if this is the case, then this side represents our 2x rule. Across from the 30 is your x side. Across from the 60 is your x square root 3 side. So if 2x is 16, that would mean that x has got to be 8. Divide by 2. Okay. Take that same x and plug it in here. Okay. We have that our base is 8 square root 3 and our height is 8. All right. This is another one that a lot of students missed on the test. Hold on, Lucius, I'm doing a video. Okay. So, all right. So with this problem, we're trying to find this length here. Okay. Most students are able to pretty obviously identify that this is a 30, 60, 90. Which means that this is the 2x side, across is your x side, and then across from 60 is your x square root 3. So if 2x is 12, that means x is 6. Plugging that in here, this is 6 square root 3. Now, when students have problems, this is usually where they get stuck. They don't know where to go from here. So you have to practice reading, okay? It says a square logo is design has a strip of uniform width along its design represented by the white section. What is the approximate measure of A? So because this is a square, that means that this side, that length, is the same as this length. Okay. So if this length is 6 square root 3, okay, from here to here, we know that this piece is 6. You just subtract. Now, another common mistake is that students will go, okay, 6 square root 3 minus 6. They'll cancel the 6's and say their answer is square root 3. That's not correct. If you know order of operations, okay, parentheses, exponents, multiplication, division, addition, and subtraction, multiplication and division come before addition and subtraction. You can't subtract the 6's because this is multiplication. It's 6 times the square root of 3. You have to do that first before you subtract. So really, you have to convert this to a decimal. 6 square root 3 as a decimal is 10.39 about. Subtract 6, and we get our answer is about 4.39. Number 13. What is the value of x and y? So this is a SOHCAHTOA problem. We're working with this angle here, and we've got to use different SOHCAHTOA functions in order to get x and y. So I'm going to start by labeling this with what my opposite and adjacent and hypotenuse sides are, since we know that that's what this is going to that's what's going to tell us which proportions to use. So across from your angle is always your opposite side. Okay? Hypotenuse is always across from the right angle. And then the adjacent side is the one that's next to your angle. Okay? So let's say I want to solve for y first. Y is opposite. I'm given my hypotenuse. O and H means that I need to use sine, opposite and hypotenuse. Okay. So I'm going to say sine of 35 is equal to my opposite side, which is y, over my hypotenuse, which is 8. In order to get y by itself, all you have to do is multiply by 8. Okay. And then this, you put into the calculator. So make sure you're in degree mode. If you're not in degrees, you're going to get the wrong answer. 8 times sine of 35 is 4.59. That's for y. Okay. All right, for x, okay, this time we're using adjacent and hypotenuse. So adjacent and hypotenuse goes with cosine. So cosine of 35 is equal to x over 8. X is in the numerator. You follow the same process, so you end up multiplying. So we put this into our calculator, 8 cos of 35, and that gives us about 6.55. All right, number 14. So it says Jennifer is flying a kite at an angle of elevation of 65 degrees. She knows her kite string is 78 feet long. How high is the kite flying above the ground? So anytime you're doing angle of elevation problems, it's always going to involve some kind of right triangle. So you might as well just start by drawing the right triangle and then fill in the information onto the picture. So an angle of elevation means that you're starting from a horizontal line and you're looking up at something. So the angle of elevation goes with this angle in the triangle. So this is 65. So that means that this is our girl over here. Okay. Now she's flying a kite. Okay. This down here in our picture represents the ground. So this distance of 78 feet is not going to be down here. It's also not going to be over here because when you fly a kite, you don't hold it straight up like a balloon. Kites go like this. Okay? So the 78-foot long string is here. Okay? And then here's our girl, and there's her kite. Okay? And then it's asking how high is the kite flying above the ground. That's another clue, okay, that this is the side that you're solving for. Height is always going to be a straight up and down distance. Okay, so then this is the SOHCAHTOA problem again. So we are trying to find the opposite side across from our angle. We're given our hypotenuse side, which means we're going to use sine. So we say sine of 65 is equal to x over 78. X is on top, which means we're going to multiply. So x is equal to 78 times the sine of 65. Okay. Make sure you stay in degree mode when you're working on these problems. 78 times sine of 65 is equal to 70.69. Okay, next, Josh is on a building. Here's Josh. It's 210 feet high, and he's looking down at a bench in the park below. The angle of depression is 36 degrees. How far is the bench from the foot of the building? So an angle of depression is when you have a horizontal line, and then you're looking down at something. So here's our angle of depression. This is 36 degrees. He's standing on top of this building, which is 210 feet tall. So the way that we're going to get this angle to help us is because the angle of elevation and the angle of depression are actually congruent to each other, since they're alternate interior angles. So this is also 36 degrees. So then now we have our SOHCAHTOA problem. So we're given our opposite side again. Okay. This time we're trying to find how far it is from the foot of the building. So we're trying to find our adjacent side, what's on the ground. Okay. All right, so when we set this up, O and A goes with tangent. So we say tangent of 36 is equal to your opposite, which is 210, over your adjacent, which is x. You don't have to memorize that. It's on your chart, opposite over adjacent. Okay, if x is in the denominator, then when you solve for x to get it by itself, you end up dividing. 210 divided by the tangent of 36. Okay. So that's equal to about 289.04. Okay. Number 16. Below are trapezoids with the mid-segment shown. Solve for the missing distance. So if you're trying to find the mid-segment, the formula is base 1 plus base 2 divided by 2. Okay. So then we would add 28 plus 8 divided by 2. So our mid-segment is 18. Now on this problem, this time you're given your mid-segment. You're trying to find what your base is. So you have to work backwards. So instead of dividing by 2 to get the mid-segment, we're going to take the mid-segment and multiply by 2. Then instead of adding these, you're going to subtract your base. Okay. So you end up doing 2 times 19 minus 23.5. Okay, and that gives us 14.5. And of course, you can always double check your answer by going the other way. So like if I was trying to solve for my midsegment, then I would do 14.5 plus 23.5 divided by 2 gives me 19. So I know I did it right. Okay. 17. What are 4 properties of a rhombus? What are 4 properties a rhombus has that a parallelogram, or really not all parallelograms, do not? Okay. So parallelograms have opposite sides parallel, opposite angles congruent, opposite sides congruent, and that's about it. Okay. What makes a rhombus special is that, for one, it has all sides congruent. Okay. Oh, it also has the diagonals as lines of symmetry. Okay. Diagonals are also perpendicular. Okay. And the diagonals are also angle bisectors. And that's what makes a rhombus special. 18. What are 4 properties a rectangle has that a parallelogram does not? So, once again, we know what a parallelogram has. What makes a rectangle special, okay, is that it has all 90-degree angles. Okay, and those all 90-degree angles end up making the diagonals congruent. What else? Diagonals are congruent. Let me look at my notes. Okay, so we've got, here's our notes for rectangles. Something I forgot is that rectangles also have 2 lines of symmetry. Parallelograms don't have any lines of symmetry. Okay. 2 lines of symmetry. Okay, and for your 4th one, I would just pick something about the triangles. So like, one diagonal creates 2 congruent right triangles. Both diagonals create 4 congruent segments. The intersection of the diagonals creates 2 pairs of congruent isosceles triangles. Any of those would work as your 4th one. All right. 19. What is the sum of the measures of the interior angles if a polygon has 7 sides? So if you were one of my students, remember we did an activity, this activity, where we explored how when you look at, like when you take a shape and you divide it into triangles in order to find the sum of the angles, it turns out that the number of triangles that are created is always 2 less than the number of sides that it has. So that ends up making this formula that anytime you want to find the sum of the interior angles, it follows the formula 180 times n minus 2, where this is the number of sides minus 2. And it comes from the fact that when you take the number of triangles, multiply it by 180, that gives you your total angles. Okay, so plugging in 7 as our number of sides, okay, 180 times 7 minus 2 gives us 900 as the sum of interior angles. All right. Okay. Oh, we're going. We're rolling. Okay. Okay. Last 3, almost done. What is the measure of one interior angle of a regular decagon? So if you're trying to find one interior angle, all you have to do is take the sum of all of them and divide by the number of sides. So the formula ends up being 180 times n minus 2 divided by n. In a decagon, you got 10 sides. So the formula is 180 times 10 minus 2 divided by 10. Okay. Pop that into your calculator. Whoops. one interior angle is 144 degrees. Okay, I'm going to keep rolling. 21. How many sides does a regular polygon have if one interior angle is 150? So I want to talk a little bit about where this comes from because you remember formulas better if you have something to hook them onto. So with my students, what we talked about was that, let me look at these notes for a second. Okay. So if you're trying to find one exterior angle, then all you have to do is take the number of sides, or sorry, if you're trying to find the number of sides and you're given an exterior angle, then all you have to do is 360 divided by the exterior angle. And we worked out how it comes from this formula, and if you solve this formula for n, then this is what you get. Now, trying to solve this formula for n gets pretty complicated. But remember, an interior and an exterior angle sum to 180. So really, you can just take this formula, and instead of plugging in your interior angle, solve for your exterior angle by subtracting 180. And that's where this formula comes from. It's the same formula, but if you're given an interior angle, in order to get the exterior, you subtract it from 180. Okay. So, with that said, so our formula would be 360 divided by 180 minus 150. Okay. 180 minus 150 is 30. That's also what your exterior angle is for this polygon. Okay. 360 divided by 30 is equal to 12. So this has 12 sides. All right, last problem. Okay, so it says below is a regular pentagon with the apothem and radius shown. What is the perimeter of the pentagon? All this stuff goes to the other problem, so just ignore that stuff. Okay, anytime we're doing apothem problems, it's going to involve SOHCAHTOA in some way. Yesterday, we did a lot of problems where you were given a side and you had to solve for the apothem. This time it's backwards. Okay? We're trying to find the perimeter, which is all of these outside edges added together. Okay? So it would be helpful if we knew what this length was, because we know the apothem is a bisector, which means that this is the same. So if we have this, we can multiply by 2 to get a side, and multiply that by 5 to get the perimeter. So that's what we're going to do. Okay, I'm going to do a little scratch work over here. So you have to start by figuring out what one interior angle would be, because we're going to use that interior angle to get this angle. So we're going to use the formula we used before, 180 times n minus 2 divided by n. In this case, n is 5. Okay, so I'll show you on my calculator. 180 times parentheses 5 minus 2 divided by 5 is 108. Okay? Now, 108 is the measure of the whole angle. We want half the angle. So 108 divided by 2 gives us 54. Okay, I'm going to draw that triangle a little bit bigger over here. So this is 54, this is 6, and we're trying to find this length down here. Okay, so using SOHCAHTOA, this is our opposite side, this is our adjacent side, which means we need to use tangent. So tangent of 54 is equal to 6 over x. Since x is in the denominator, we're going to end up dividing when we solve for x. Okay? So plugging that into the calculator, 6 divided by the tangent of 54 gives us about 4.36. Okay. Now I bet you that on the test, this is one of the answer choices. But this is not your final answer. Okay, it's asking for the perimeter. You got half a side length. That's what 4.36 is. This piece would also be 4.36. Okay, so one side, okay, would have a length of 8.72. There's 5 of them. So your total perimeter would be 43.6. Okay. Good luck on your test tomorrow. I hope you do well, and have a good night.